Hi, fourth graders, Unit 2, Lesson 2 on page 47 of my SAB. So here we're using place value to multiply. It says you have learned about the base 10 pattern in place value. This model shows how place value and multiplication are connected. So let's check out the model here. Here we have two tens, and showing that if we want to regroup tens into hundreds, we have to have 10 tens for 100. 20 groups of 10, 2 times 10, or 10 times 20. And then you can see that each one of these columns, when you move it over to the hundreds, becomes 100. So look at that, kind of observe it a little bit. We're going to be looking at the property that I told you about in the last lesson, the associative property, as well as the commutative property. Okay, so let's see here. This is gonna look pretty crazy at first, so just bear with me. We're gonna take it nice and slow. So the associative property shows the relationship between place value and multiplication. Here's how it does it. First of all, here, just your plain problem here, 10 times 20. That's your multiplication problem that we're demonstrating. Then on the other side of the equal sign, we're going to show that we can play around with these numbers and change them around a little bit. As long as we keep the place value correct, we can get the same answer. So let's try it. Over here, and maybe I will cover up what's underneath so we can really just focus on that top one there. Over here, we have the 10. There's the 10. Times, and instead of saying 10 times 20 like they did here, it says 10 times 2 times 10. Do you see how, like in the last lesson, they just break up that 20 into a multiplication problem? So the reason it's showing place value is because it's a 10, so there's 1 0, there's one place after the first number, so that means it's showing the tens place. So if you have a hard time thinking about this, you could just think, okay, they're breaking apart the 20, and they're showing it by saying 20 is the same thing as 2 times 10. Now, to show the associative property here that we have, we're going to show that we can change the order of how you solve this. So instead of having the parentheses around the 2 and the 10 like they did up here, they're moving the parentheses to around the 10 and the 2. Everything else stays the same, 10 to 10, 10 to 10. It's just that the parentheses moved. You might remember that when you're doing an equation, when you're solving an equation, parentheses are what you solve first. So if I was going to solve just this first one, I would first solve 2 times 10 equals 20. 20 times 10 equals 200. Then on this one, I'm solving 2 times 10 equals 20, same thing, right? Times 10 equals 200. Now, the commutative property shows us that inside these parentheses, we can flip-flop the numbers, the order. And this is something that you've known for a long time in multiplication, that 10 times 2 is the same thing as 2 times 10. And then they kept the 10 on the outside the same there. Okay, so here is another way that they're using the associative property. So I'm actually going to cover up all this front stuff now so we can see fairly easily. Here is the problem, 10 times 20. And we're showing it in a different way. So we can show 10 times 20 as 2 times 10 times 10. What? Where did they get that? Well, they pulled out this 2 and they put it here. And then because the 2 is here to give it that 200, now they just had to figure out a way to show that there'll be 2 zeros in the answer, because as we know, the answer is going to be 200. So 2 times, and then here's the place value part. We have to get up to 100. Oh yeah, 10 times 10 will get us up to 100. And then here they're showing that they've solved that 10 times 10 by writing 100. So 2 times 100 equals 200. So these are tricky only because sometimes it's hard to know what numbers you should write where. But as far as the actual math problems, they're not that bad. It should be pretty obvious that 10 times 20 is 200 because 1 times 2 is 2, and then you just stick 2 zeros after it. There's a 0 there and a 0 there. So 200. Let's see what we can come up with here in number 1. 10 times any number of tens gives you that number of hundreds. Complete the steps to show 10 times 5 tens. Okay, so here we have 10 times 50. So looking at the first one, 10 times, and then how can we show 5 tens? How about 5 times 10? Would that show 50? Yeah, okay, cool. So 10 times 5 times 10. Now remember that associative property, it wants us to use those same numbers, but we just are switching where the parentheses are. So 10, 5, 10. It should be the same down here. 10, 5, 10. But they've moved where the parentheses are. That's the only change. Now moving down here, they're going to show that commutative property. And you guys, I know what I'm doing because I'm looking up here. So you can always look up here and see what they've done. Or when you're doing your online lesson today, you could look right here on this page because you've copied down the answers. Okay, so now what we're doing is we're just showing that you can flip-flop the 10 and the 5. So instead of 10 times 5, it's going to say 5 times 10. And then the 10 on the outside stays the same. Now, I wonder if we can show the 5 on the outside and then show to get up to 500 by showing 10 times 10. So what this is doing is this is pulling out just that 5, and then, because we know the answer is going to be 500, right? 10 times 50 is going to be 500. So then we have to think of a way to show the place value, 5 times 10 times 10. And then this next row is simply showing us the answer to 10 times 10 equals 100. The 5 stays the same on that one. Phew! And then 5 times 100 equals 500. You are not alone if this seems kind of wacky and kind of confusing. It always is at the beginning of 4th grade. My best advice when you're doing your online lesson is have this open so you can see the pattern. You can see it done once here. You can see it done again here. They're going to use the exact same pattern. So in that way, hopefully it helps make it a little easier. Okay, here we are on the next page, page 48. Model a product of tens. Olivia wants to tile the top of a table. The table is 20 inches by 30 inches. Olivia needs to find the area of the table in square inches. Find the area of this 20 by 30 rectangle by dividing it into 10 by 10 squares of 100. You could spend a lot of time doing that. You could also simply, I think this is actually what they're saying, just divide it into hundreds. It doesn't have to be perfect, it just needs to be visually easy for you to see. And remember that each of these boxes is 100. Number 3, each tile is a 1-inch square. How many tiles does Olivia need to cover the tabletop? What do you think? This is 100 too. 1, 2, 3, 4, 5, 6, 600. Each box of tiles contains 100 tiles. How many boxes of tiles does Olivia need to buy? If she needs 600 tiles and each box contains 100 tiles, how many 100s are in 600? 6. 600s are in 600 because 6 times 100 equals 600. Okay, so here we are factoring the tens. Complete the steps to show your work in exercise 2. So, again, using their clues to help us, we see that 20 times 30 is what's over here. And we already know the answer because we figured it out already. It's 600. So now in these blanks, it's breaking apart the 20 and breaking apart the 30. So if I'm going to break apart the 20, what times 10 equals 20? 2. What times 10 equals 30? 3. See how I did that? Now we're just going to change the order of how these numbers are listed. So here are the 10 and the 10. So I've already used the 10 and the 10 from up there. What 2 numbers are left? So I put the exact same numbers in this row, 2 and 3. And what they're showing us is that now the 2 and 3 are together, buddies in parentheses, and the 10 and the 10 are over here together. Anytime you start seeing the equation get shorter, it means that it's starting to be solved. So where do you think this 100 came from? Do you think it came from these buddies or these buddies? It came from over here. 10 times 10 equals 100. And then what would go here? The answer to these buddies, 2 times 6 equals 6. And then 6 times 100 equals 600. Is it true that 20 times 30 equals 30 times 20? Explain how you know. You would say, yes, I know this because you can change the order of the numbers in a multiplication problem. If you wanted to get really fancy, you would say, I know this because of the commutative property of multiplication, which states you can change the order of numbers in a multiplication problem. All right, fourth graders, thank you for your attention. Good luck on your lesson today.